Welcome to the deep dive.
Right.
Today we're setting our sights, well, way up on space mining. It's a frontier that feels both incredibly far off and maybe absolutely key to our future.
Mhm.
We've got some really interesting information here looking at how tapping resources on the moon and asteroids could, completely shake up space exploration and maybe even things back here on Earth.
Right.
So our mission today is to really dig into the potential locked up in moon dust and those metal-rich asteroids we keep hearing about.
And it's definitely picking up speed. The stuff we've looked at shows a lot of momentum, doesn't it?
Yeah, it seems like it.
Global initiatives are popping up, aiming to make this real, like within this decade. It's ambitious stuff.
Super ambitious. Okay, so where do we start? The moon, our nearest neighbor.
Makes sense. Let's start there.
Right. So beyond the dust and craters we all know, the info points to some serious resources. First step, helium-3? Something like 1 million tons.
Yeah, around that estimate, helium-3.
Now, why is that such a big deal for anyone listening who's wondering?
Well, it's all about fusion energy. Helium-3 is seen as this potential clean fuel for future fusion reactors.
Cleaner than other types.
Exactly. Unlike the fusion reactions most labs are working on now, helium-3 fusion produces almost no radioactive waste. That's the huge draw.
Okay. And 1 million tons. How much energy is that, roughly?
Well, some analyses suggest just a few dozen tons could power a city like London for a year. So yeah, 1 million tons. It's potentially transformative for energy if we nail fusion technology.
Right. Big if, but still, yeah. And it's not just energy, right? There's water ice, too. Billions of tons.
Billions. Yeah, mostly tucked away in those permanently shadowed craters near the poles.
Which must be tricky to get to.
Oh, definitely logistical challenges there, but the payoff could be enormous. Think of it as an in-space resource depot.
For astronauts.
For astronauts, yes, but even bigger picture. You split that water ice electrolysis into hydrogen and oxygen.
Rocket fuel.
Bingo. Rocket fuel. That's what we call in-situ resource utilization, or ISRU. It's absolutely key for making deep space travel sustainable, cheaper.
Because you refuel out there instead of hauling it all from Earth.
Precisely. It cuts down your launch mass dramatically, extends mission range. It changes the economics completely.
Makes total sense. Okay, what else? The moon's got more surprises. Our info mentions rare earth elements.
It does. Concentrations in some spots might actually be higher than what we find here on Earth.
And those are vital for, well, almost all our tech, aren't they?
Pretty much. Your phone, electric cars, wind turbines, medical gear, they all need rare earths.
And right now, the supply chain can be a bit tricky, geopolitically.
Or putting it mildly sometimes, yes. Sources are very concentrated geographically, so the moon could offer, a diversified, maybe more secure supply.
Interesting. And we shouldn't forget the moon dust itself, regolith.
Right. That loose layer covering everything. It's abrasive, sure, challenging stuff, but you could potentially process it into building materials, think lunar concrete.
Building on the moon with the moon.
Exactly. And it's also pretty good radiation shielding, so useful for habitats.
Okay, the moon is looking like a seriously valuable piece of real estate. Let's pivot to asteroids now, because the numbers there sound, frankly, astronomical. Trillions of dollars in metals.
The estimates are, staggering, especially near Earth asteroids. They're like floating treasure chests.
Give us an example.
Okay, take a platinum-rich asteroid, maybe 500 meters across, not huge in cosmic terms. Some analyses figure it could hold more platinum than humans have ever mined on Earth.
More than all platinum mined in history, from one rock.
That's the potential, yeah. It just gives you a sense of the scale we're talking about. Mind-boggling.
It really is. And it's not just the shiny stuff, is it? These C-type asteroids.
Yeah.
They have water, too.
That's right. C-type, carbonaceous asteroids. Lots of water, plus organic compounds, just like the lunar ice.
And you can make rocket fuel.
Exactly. They become potential filling stations dotted around the solar system. Imagine spacecraft hopping between them, refueling as they go.
That completely changes how we think about long journeys, doesn't it?
Fundamentally. And then you got the M-types. Metallic. Think iron, nickel, cobalt. Really high concentrations, maybe up to 10 times what you find in the richest mines here on Earth.
Wow. So that's material for building things in space. Or even bringing back.
Both, potentially. Invaluable for in-space construction, definitely. Bringing bulk materials back to Earth. Well, the economics of that are still being worked out, but it's not impossible.
Okay, so we've established this incredible potential out there. Let's talk about how using it in situ like you said, changes space exploration itself. It's not just about bringing stuff home.
Not at all. That's the real revolution, I think. Using resources locally. In space, manufacturing and construction.
Right.
Our sources suggest this could slash launch costs, maybe by as much as 90%.
90%, just because you're not lifting everything from Earth.
Exactly. Think of the fuel saved just escaping Earth's gravity well. If you can build structures, spacecraft, components in space using space resources, it's a total game changer.
And we're talking actual habitats,
Yeah.
factories.
Yeah. NASA's got programs like Impact-T looking at 3D printing with Lunar regolith. Imagine printing landing pads, habitats, even roads on the moon using the local soil.
That makes long-term stays, actual bases, seem much more feasible, less reliant on Earth.
Nor more realistic and affordable, yes.
Yeah.
Suddenly, a sustained human presence isn't just sci-fi.
And the water ice plays back into this too, extending missions.
Crucially, process that ice into propellant, set up refueling depots, maybe at Lagrange points or in lunar orbit.
And suddenly you've got the infrastructure for constant interplanetary travel, not just one-shot missions.
That's the vision. Self-sustaining outposts using local resources. It becomes a real possibility.
A very compelling picture for space. Okay, let's bring it back down to Earth for a minute. What are the economic ripple effects here?
Potentially huge. The overall space economy is already big, right? Around $469 billion in 2021.
And growing fast.
Projected to hit over $1 trillion by 2040. Space mining is expected to be a major driver of that growth. New markets, new opportunities.
And you mentioned cost reductions earlier. Accessing space itself gets cheaper.
Yeah, using local resources is estimated to cut the cost of getting to space by maybe 30 to 50%.
That alone would spur more activity, wouldn't it?
Absolutely. Lowering that barrier to entry fuels innovation. Plus, you'll see whole new industries emerge. Space-based manufacturing, construction, logistics. Companies focus entirely on leveraging these off-world materials.
It sounds like a positive feedback loop.
Yeah.
More resources mean cheaper access, means more activity, means more economic growth.
That's the hope, yes.
Okay. What about the impact on our existing industries and supply chains? We talked about rare earths. Could space mining solve some of those bottlenecks?
It's a key part of the discussion. Those rare earths, vital for green tech, EVs, wind turbines.
Right.
They often have complicated supply chains, geopolitical strings attached. Getting them from the moon or asteroids could, well, diversify things, reduce some of that risk and tension.
That could have major strategic implications globally. And other materials, like platinum from asteroids.
Yeah, platinum group metals. Essential for catalytic converters, but also crucial for hydrogen fuel cells.
Which are key for cleaner energy.
Exactly. If asteroids offer a much more abundant source, it could really accelerate the shift towards hydrogen tech, revolutionizing production.
Are there, and this might sound odd, environmental benefits to mining in space?
It does sound counterintuitive, doesn't it? But yes, potentially.
How so?
Well, for starters, less need for massive mining operations here on Earth. That means less habitat destruction, less pollution.
Okay, makes sense.
Plus, if you can move certain heavy manufacturing processes off-planet, processes that are dirty or dangerous, you eliminate that impact on our biosphere.
And long-term?
The really big vision, building huge solar power satellites in orbit using space materials, beaming clean energy down to Earth 2047, that would be transformative.
Wow. Okay, that's a serious potential upside. But big shifts always cause disruption, right? What happens to existing industries?
We're already seeing some adaptation. Major terrestrial mining companies are actually investing in space mining ventures now.
They see the writing on the wall, or just hedging their bets?
Probably a bit of both. They recognize the long-term potential.
Yeah.
But yeah, if suddenly you have vast new supplies of metals coming from space, that will likely cause volatility in commodity prices.
Sure.
And you'll likely see new, specialized companies springing up just for space logistics, getting the stuff from A to B. That creates new opportunities, but also challenges for established logistics players.
A complex picture then. Huge potential, but definitely adjustments needed. Let's get practical. How do we actually get this stuff? What tech is being worked on?
The challenges are immense, no doubt, but the progress is exciting. For water ice on the moon, you've got NASA's Viper rover getting ready. Its whole job is to go prospect for ice.
Sniffing out the water?
Pretty much. For building things, there's microwave sintering of regolith, basically zapping the moon dust with microwaves to fuse it into solid blocks.
Like a cosmic 3D printer?
Sort of, yeah.
Yeah.
And even wilder stuff, like biomining experiments on the ISS, using bacteria to help extract metals.
Using microbes? Seriously?
Yep. Seeing if certain bacteria can help leach out valuable elements in microgravity. Still early days, but very innovative thinking.
Incredible. Okay, so you extract it, then you've got to move it. Another massive challenge, I imagine.
Huge. For moving asteroids or big cargo loads slowly but efficiently, solar electric propulsion is a key technology. Gentle, continuous thrust, very fuel efficient.
Takes a while, though.
Takes a while, yeah. Not for speedy trips. Then you've got more advanced concepts being looked at: tether systems, mass drivers that could fling payloads without propellant.
Sci-fi stuff becoming reality.
Hopefully. And for the moon, because the gravity is lower, things like lunar elevators might actually be feasible with materials we have, or are close to having. Much more achievable than an Earth space elevator.
Okay, so the engineers are busy. What about the lawyers and politicians? Who owns this stuff? What are the rules?
The million, or maybe
Ah.
trillion-dollar question. The legal side is still very much under construction.
Figuring it out as we go.
Kind of. You have the U.S. Commercial Space Launch Competitiveness Act from 2015, which says U.S. companies own what they extract. That was a big step.
Okay.
Then internationally, you've got the Artemis Accords, started in 2020. It's a set of principles for cooperation, including on space resources, among the countries that sign up.
But not everyone signed up.
No. And the UN Committee on the Peaceful Uses of Outer Space, Kadosh US, is where the broader international discussions are happening, trying to develop norms. But it's slow going.
So a work in progress. Definitely something to watch. Okay, let's wrap up with some cool stories, making this feel real. The sources mentioned some great examples, like the trillion-dollar asteroid.
Right, that's Asteroid 16 Psyche. The estimates are just wild, maybe $10 quintillion worth of metals. Nickel, iron, gold, platinum.
Quintillion, that's a lot of zeros.
More wealth than the entire global economy, by far. NASA launched a mission, Psyche, in 2022, just to go study it up close.
Just imagine the first company to actually mine something like that.
Exactly. The economic implications are almost too big to comprehend.
And 2023 seemed like a big year for the moon, right? A moon rush.
Yeah, definitely a surge in activity and announcements. China landed Chandy Sucks and brought back samples from the South Pole, super important for understanding those ice deposits.
And private companies.
We saw the first attempts at commercial lunar landings by companies like Astrobotic and ispace. They hit some snags, which isn't unexpected for first tries.
Sure, space is hard.
Space is hard,
Yeah.
but it signals the start of commercial operations, prospecting, trying to make a business case on the moon.
And who are these modern space miners? It's startups? Big aerospace.
It's a mix. You've got former NASA engineers designing asteroid capture tech in their own companies. You've got startups like Astroforge, who actually launched a demo mission in 2023 to test their mining tech.
Wow.
And as we mentioned, even traditional mining giants like Rio Tinto are putting money into R&D. That tells you something.
It really does. And this idea of the first space resource economy taking shape, are we seeing the beginnings of that?
The pieces are starting to come together. Some analysts think we could see the first, maybe small-scale, lunar water mining operations by 2026.
Not soon.
Potentially. And companies like Made in Space have already shown they can manufacture things in orbit. The next step is doing it with off-world materials. Some projections even see the first fully space-made satellite by maybe 2028.
Built-in space with space stuff.
That's the goal. So yeah, it feels like the very early days of an economy moving beyond Earth.
This has been absolutely fascinating. A real deep dive into something that could completely reshape our future. The potential seems almost limitless, revolutionizing exploration, resources, the economy.
Immense potential, absolutely.
Yeah.
But the challenges, technical, economic, legal, are just as big. We shouldn't underestimate them.
Definitely not.
But getting this right could fundamentally change our whole relationship with space, couldn't it? Moving from just visiting to actually, living and working out there sustainably. The next decade feels crucial.
It really does. So here's something to think about as we wrap up. We've seen incredibly rapid developments, even just in the last year or so. As we get better at accessing and using resources off Earth, how does that change our fundamental ideas about value, about ownership? What does it mean when potentially planet-changing wealth isn't tied to any nation on Earth? It's a huge question for the coming decades.
A very profound one.
Thanks for joining us on this deep dive.